All right, hello, hello. Geometry, here is your practice quiz review. I'm going to go through it pretty quickly because you guys can pause if you need to, and I think you're going to do really well on it regardless. All right, use the figure at the right. We've got JK is 4x plus 10, and NO is 21. So hopefully we are noticing that those are mid-segments drawn there. And so this mid-segment NO is going to be half of 4x plus 10. All right, so we could either, take half of this and set it equal to 21, or we could double the side here and set it equal to 4x plus 10. And I think that's going to be the easiest thing. So 4x plus 10 is equal to double 21. Okay, so 4x plus 10 is equal to double NO. All right, so 4x plus 10 is equal to 42. 4x is equal to 32. X is equal to 8 here, and that's what we've been asked to find. X is 8. So you certainly could have said that 21 is half of 4x plus 10, but then you have to distribute and make sure that you do everything correctly, which is fine. It's just nice to see it both ways, and I like to, show you that so that you can see the consistency here. So you could solve it either one of those two ways. I just think this one's easier to double the mid-segment and have it equal to the third side, but you can always have the third side and have it equal to the mid-segment. All right, so the next one, we got lots of mid-segments going on here. So name the segment that's parallel to the given segment, RS. That's easy. There's the mid-segment, and it is certainly parallel to this third side here. RS is parallel to, let's just call it by the endpoints and do alphabetical order YZ. Okay? Technically, you could say ZQ, Z, ZY, lots of ways to do that. Points D and H are the midpoints sides of TUV, so mid-segment here. UV is going to be 50, so this whole thing is 50. TV is 62. And HD is 50 in here. All right, so this little guy. Find HE. So HE, so they've given us some information that we don't need. HE is just going to be half of this UV. So HE is simply going to be half of 50. HE is 25 there. So some information you did not need. You did not need this 62, and you need this other 50 in here. So that was unnecessary information. All right, find the value of x here. Let's see if we can see that a little closer. Again, a mid-segment situation. So you could easily say that 5x is equal to 30, half of that 60. Or you could say that 60 is equal to double the 5x. Either way, you're going to get x is equal to 6. Okay, next one, another mid-segment. Not many topics here, so you're going to get some repeated type problems. X plus 5 is equal to 20. X is equal to 15. Or x plus 5, 40, you could double this. And 2x plus 10 is equal to 40. And so 2x is equal to 30. And x is equal to 15. Either way you approach the problem, I guess I already had an x there. Either way you approach the problem, you are going to get 15 there. All right. So looking good. Next page. X is the midpoint of UV. And y is the midpoint, so we can mark these. Okay. And then this angle down here, this angle right here is 43, and so we're asked to find this angle. Okay, so they're just linking in some parallel line properties here. It's the mid-segment, so that's parallel. So basically, you could extend these, and you could cut them by this transversal, and look what you have. You have corresponding angles. So this is also going to be 43 by corresponding angles. So it's kind of neat to see the part of semester one coming in. They're both on to the left of the transversal and above the parallel lines. Okay, number 7, IJ is a midsegment of triangle FGH. IJ is 11, and it's a midsegment. FH is 15, so this whole thing is 15. And GH is 19. Okay, so find the perimeter of IJH. Okay, so the perimeter, this is 11, so this is going to be 7.5, right? That's going to be half because that's a midsegment, so that's a midpoint. And then this is going to be 9.5. All right, so we are looking at this problem, and we are going to be just adding for this little triangle, 7.5 plus 9.5 plus 11 is the perimeter of FGH, perimeter of FGH. Okay, so what do we get here? 17 plus 11, and that is 28. Perimeter of triangle FGH. Perimeter of triangle FGH. 28. Use the figure on the right to find the length of DC. Okay, we're switching into 5.2 right now where I see a perpendicular bisector. Perpendicular bisector is going to guarantee that the sides, that A is equidistant from D and A is equidistant from B. So I can certainly make this 14, and then this will also be a right angle but a linear pair postulate. They make a line, they're supplementary, 90, 90. So you also have a perpendicular bisector here, so this is 16, and I believe that is what was asked for. All right, what is the value of C here? So perpendicular bisector, Z, not C. So that's telling us that M is equidistant to both endpoints there. So it's equidistant to J and K, so I can set those. And 9Z minus 12 equals 3Z. 6Z equals 12. Z is equal to 2. Value of Z, we get 2 there. All right, find the value of Y. Okay, find the value of Y. So now we've got the angle bisector situation. So if you have angle bisector and a perpendicular path, then you can mark these sides over here. Angle bisector, perpendicular path, mark these congruent. Well, they're already marked congruent, so we're going in reverse. And we're saying that if they're marked congruent on a perpendicular path, this is a converse. You can just set these two equal to each other because that would have to be an angle bisector for these to be congruent on a perpendicular path. Okay, so 8y equals 6y plus 20, 2y equals 20, y is 10. Okay, so first page done. Let's go on to the next page here. Number 11, we have the angle bisector marked, the perpendicular path, so those guys are equivalent. 5y equals 3y plus 6, 2y equals 6, y is equal to 3, and then ST is just going to be 5 times 3, which is 15, and TU is going to be 3 times 3 plus 6, which is also 15. And those, those should check to be the same when you plug in because the angle bisector theorem says they'll be congruent. Perpendicular bisector is going to guarantee that these sides are the same. 6x minus 6 equals 3x. No, 6x. I wrote 3 is a 6. 6x minus 6, that's 3x equals 6x is equal to 2 here. 6x minus 6 is 3x. That is 3x. 6x is 2, so TW is 3 times 2, which is 6. Okay, can a triangle have these given lengths? Explain. All right, so the two shortest, so 1 plus 5 must be greater than 10. 6 greater than 10. No, that doesn't work, so false. So this is a no. Okay, so let's choose between this and this. 10 plus 1 contradict? No. Does 1 plus 5 being less than 10 not support triangle theorem? That's correct. So this number 13 is D. List the triangles from smallest to largest. So we're going to go to the sides here. So this is going to be the smallest because it's across from the smallest side. Middle because it's across from the smallest side. And largest because it's across from the biggest side. So 2.8 across from the smallest, or 2.8 is the smallest, so K is the smallest. 4.1 is the middle, L is the middle, 6.5 is larger, so M is larger. So what am I going to say? KLM. KLM right here. Okay, 14 is B. 15 lists the angles of the triangle from order to smallest. All right, so I'd probably draw this. I'd go A, B, C. BA is 8. CA is 9. C is 4. Smallest, middle, largest. Smallest to largest is going to be A, C, B. A, C, B. And that's letter C. Okay. 16 lists the sides. List the sides in order from the shortest to the longest. Calculator, and just see 180 minus 97 minus 40 is 43. Okay, so smallest, middle, largest. Okay, so in terms of the sides, that means that this will be the smallest side, this will be the middle side, and this will be the largest side. Okay, so the smallest side then is NO. The middle side, no, smallest side is ML, sorry. ML. Sorry, I can't, I'm getting my letters. Okay, MO, and then NO, and then MN. All right, so where do we see that? OM, NO, NM. All right, E. So that one's going to be E. So lots of letters, lots of things to keep straight. And I probably did too much labeling there with S, L, and M, and then I got myself confused. So anyway, that's E. There you go. Going on to our last page here, which is going to be here. A triangle has side lengths of 7 and 3. What can you say about the length of the third side? Well, it will be between 4 and 10. So it's longer than 4, but not necessarily shorter than 10. That doesn't make any sense. 3, side is longer than 4 and shorter than 10. There you go. So 17 is going to be G there. And then here, same type of question. So subtract those for 6, third side, and 12, right? And so the side is going to be longer than 6 and shorter than 12, right there. It's right the first answer. All these other ones are just super confusing to read. All right, last one is determine which segment is the shortest in the diagram. So these two triangles have to be independent of each other. You do the smallest angle in the whole diagram. You just want to look at the two separates. So 180 minus 99, this is going to be 81 right here. And then 180 minus 99 minus 35, this is going to be 46 right here. Okay, so let's see. In the first triangle here, 99, 35, and 46, 35, this is going to be the shortest. Okay, so that's going to be the shortest in that triangle. However, in this triangle, it's going to be the middle side because it's across from 50 and actually across from 49 is the shortest. So, you know, you've got AC is the shortest in triangle ACD, but AC is the middle in triangle ABC. So that means there is one shorter, right? And that has to be BC. So that's the overall shortest. So this really confuses people because they just want to say, but 35 is the smallest degree, so this has to be the shortest side. And that's not true. It's got to be the shortest side in that triangle, but it doesn't apply to the other triangle because these are angles. You know, it's just like if this is a square, this is 3, and this is a square, does this have to be 3? No. This could be, 10, and that's fine. And these are angles. So yes, within here, across from 35 has to be the shortest, but in this other one, it doesn't. You don't have to compare it to that original triangle. And you can always just put some numbers in here. If this is the shortest side, say it's 5 centimeters, okay? And it's still 5 centimeters over here, right? It's still 5 centimeters. That stays. But there's something shorter, so maybe here is 3 centimeters. It just depends on how wide the angle is expanded. And that figure's not drawn to scale, so it's a little easier when the figures are drawn to a little bit of a better scale. All right, guys, good luck on your quiz in class, and we'll see you soon. Have a good one.